Now, in this lecture, we'll find out the radius of a circle. In the drawing, we have a circle. We know that chord AC equals to the square root of 2 units in its length. Chord DB equals to 2 units in its length. And also, here, this is angle BED. This is equals to 45 degrees in its size. In addition, we have here chord AB and chord CD. And our mission is to find out the radius of this circle. So first of all, we join points A and D together by a straight line. And we define the size of this angle BAD as x over 2. Again, this is angle BAD and it is equals to x over 2 according to our definition. Actually, we have here peripheral angle BAD, this is peripheral angle BAD, is equals to x over 2 degrees in its size. The next step, we define the center of this circle. This point is point O. We join points O and B together by a straight line. We join points O and D together by a straight line. By doing this construction, we created the center angle BOD. This is the center angle BOD, and the center angle BOD subtends on chord BD. And we also have here peripheral angle BAD subtends also on chord BD. So the center angle BOD subtends on the same chord as the peripheral angle BAD. So here we can implement rule 13. According to rule 13, the center angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and this is peripheral angle ACB that subtends on chord AB. And the size of this peripheral angle ACD is equals to theta. In addition, we have here center angle AOB subtend also on the same chord called AB. Therefore, according to this rule 13, the size of the center angle AOB will be twice as large as the size of this angle, the peripheral angle ACB. We know that this peripheral angle ACB equals to theta, therefore the center angle AOB that subtends on the same chord called AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. In our drawing, we have peripheral angle BAD subtend on chord BD, and the center angle BOD, this center angle BOD subtend on the same chord called BD. Therefore, the size of this center angle must be twice as large as the size of this peripheral angle BOD that subtend on the same chord called BD. So the size of peripheral angle BAD is equals to x over 2, therefore the size of this central angle BOD must be equal to x, according to Rule 13. In the next step, we will define the size of this peripheral angle ADC as y over 2 degrees. This is peripheral angle ADC that subtends on chord AC. So in the next step, we join points O and N together, O and A together by straight line. And we join points O and C together by straight line. So by doing this construction, we can do center angle CAOC. This is center angle AOC that subtends on chord AC, and peripheral angle ADC subtends, this peripheral angle ADC subtends on the same chord called AC. Therefore, according to Rule 13, the size of this peripheral angle, of this center angle AOC must be twice as large as the size of this peripheral angle ADC. So the size of this peripheral angle ADC equals to y over 2. Therefore, the size of this center angle AOC that subtends on the same chord called AC must be equal to y, twice as large as the size of this peripheral angle ADC, that is y over 2. Okay. So, in the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is Rule 4. According to Rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing, this is a triangle, and inside this triangle we have three interior angles. A, B, and C are the three interior angles, and we have also here, this is angle E, that is an exterior angle. According to this rule 4, the size of this exterior angle E will be equal to the sum of the two interior angles that are not adjacent to it. Which interior angles are not adjacent to angle E? Angle C adjacent to angle E. The other two angles that are not adjacent to angle E is A and B. And the sum of those two angles is A plus B. So the exterior angle E equals to A plus B. This is the sum of the two interior angles that are not adjacent to it. Okay, so the size of this interior angle E is equal to A plus B. So we can actually implement Rule 4 in our drawing. Why? Because in our drawing we have this is triangle DEA. Inside triangle DEA, we have two interior angles that are x over 2 and y over 2. And this is angle DEB, that is equal to 45 degrees. In relation to triangle DEA, is defined as an exterior angles. So now we can implement Rule 4 in our drawing. According to Rule 4, the size of this exterior angle E, that is 45 degrees, must be equal to the sum of the two interior angles that are not adjacent to it. This angle adjacent to the angle that is equal to 45 degrees in size. The other two angles that are not adjacent to this angle that is 45 degrees are x over 2 and y over 2. So according to rule 4, the sum of the two angles that are not adjacent to this angle that is 45 degrees are x over 2 plus y over 2. So if it again, according to rule 4, the exterior angle that is equal to 45 degrees in size must be equal to x over 2 plus y over 2. So I write it down. If we found out that this is the exterior angle DEB that is equal to 45 degrees in its size. And this exterior angle equals to the sum of the two interior angles that are not adjacent to it. That is to say it is equals to x over 2 plus y over 2. So I repeat again. So we actually found out that according to rule 4, the value of the exterior angle that actually equals to 45 degrees, it must be equal to the sum of the two interior angles that are not adjacent to it. That is to say, it must be equal to x over 2 plus y over 2. Here we will multiply this according to rule 4, of course. Here we will multiply this equation by 2, and we get that 45 degrees times 2 is 90 degrees. It is equals to x plus y. Here we subtract x from this equation, and you get that y equals to 90 degrees minus x. So this will be equation 1. Y equals to 90 degrees minus x. Okay. We have the trigonometric identity, but we found that we have the law of cosines. According to the law of cosines, the law of cosines is true in any triangle. So if we have a triangle ABC, that could be any triangle. This is triangle ABC. The size of side AB is A. The length of side AB is A. Side AC equals to B units in its length. Side BC equals to C units in its length. And this is angle theta. According to the law of cosines, C square equals to A square plus B square minus 2 times A times B times cosine theta. Okay. So here we get 2 times AB cosine theta to this equation, and we get that 2 times AB cosine theta plus C square equals to A square plus B square. Here we divide this equation by 2 times AB, and finally we get that cosine theta But before that, we subtract c squared from this equation, and we get that 2 times AB cosine theta equals to A squared plus B squared minus C squared. And again, if we found out that two times AB cosine theta equals to A squared plus B squared minus C squared. Here we divide this equation by 2 times AB, and finally we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Actually, we can implement the law of cosines in our drawing. First of all, we know that point O is the center of this circle, point B is the point on the circle itself, therefore OB is the radius of this circle. That is the radius that we are looking for in this question, so we define the radius OB as R. OD is also the radius of this circle that is equals to R. OC is also the radius, and also OA is the radius of the circle. That is the radius that we are looking for in this question. So in the next step, I'll copy triangle DOB in a new page, and we'll implement the law of cosines in this triangle DOB. Side OB equals to R, side OD also equals to R, this is the radius of the circle, and angle DOD, this angle equals to X. So actually, this is triangle BOD that they come from the original drawing. Now we will implement the law of cosines in this triangle DOB. According to the law of cosines, cosine X equals to R squared plus R squared minus dB squared. dB equals to 2, therefore dB squared is 2 squared, that is 4, divided by 2AB, so it is 2, A equals to B equals to R, so it is 2 times R times R. So if we found out that cosine X, this will be equation 1, cosine X equals to R squared plus R squared is 2R squared minus 4 over 2 times R, that is 2R squared. So in conclusion, if we found out that in the triangle BOD, cosine X equals to 2R squared minus 4 over 2R squared. 2R squared over 2R squared is 1, and we have minus 4 over 2r squared. Here we will divide both the numerator and the denominator by 2, and we get that this expression in total will be equal to 1, and 4 times 4 over 2 is 2, 2r squared over 2 is r squared. So in conclusion, we found out that according to equation 1, cosine x equals to 1 minus 2 over r squared. Okay. This is according to equation 1. In the next step, I'll copy triangle ACO in the new page, and we will implement the law of cosines in this triangle ACO. Side A is equals to 2 units in its length. AO is the radius of this circle, radius that we are looking for, that equals to R. And OC is also equals to R. This is angle COA, that equals to Y. So okay, this is triangle AOC that the coordinate from the original drawing. Now we will implement the law of cosines in this triangle AOC. According to the law of cosines, this will be equation 2. According to the law of cosines, cosine y equals to r times r, that is 2r squared. Here the equation cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. So cosine y equals to a all squared, that is r squared, plus c all squared, that is also r squared, minus ac squared. AC is square root of 2, therefore ac squared is square root of 2 squared, that is 2. So it is minus 2 divided by 2ab. So it is divided by 2 times r, that is 2r squared. Actually it is r squared plus r squared is 2r squared minus 2 over 2r squared. So according to equation 2, cosine y equals to 2r squared over 2r squared is 1, and we have minus 2 over 2r squared. So we should find out that according to equation 2, cosine y equals to 1 minus 2 over 2r squared. Here we will divide both the numerator and the denominator of this expression by 2, and we get that here we have minus 2 over 2 is minus 1, and 2 r squared over 2 is r squared. So according to equation 2, we actually found out that cosine y equals to 1 minus 1 over r squared. This is according to equation 2 actually. While according to equation 1, we have already found out that this is according to equation cosine y equals to 1 minus 1 over r squared, and when according to equation 1, we already found out that cosine x equals to 1 minus 2 over r squared. We already found out that y equals to 90 degrees plus x. Yeah. Y equals to 90 degrees minus x. Okay. So now y equals to 90 degrees minus x. So now we can substitute y in this equation 2 by 90 degrees minus x. We'll do it now, and we get that cosine y is 90 degrees minus x is equals to 1 minus 1 over r squared. We know that we have the algebraic and trigonometric identity. It states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x plus sinus x. We do it now, we get that according to equation 1, cosine 90 degrees minus x is sinus x. So sinus x equals to 1 minus 1 over r squared. This is according to equation 1, while according to equation 2, we have only found out that cosine x equals to 1 minus 2 over r squared. So this is equation 1, this will be equation 2. Now we do the trigonometric identity. It states that sinus square x plus cosine square x equals to 1. We already found out that sinus x equals to 1 minus 1 over r squared, and cosine x equals to 1 minus 2 over r squared. Now we substitute sine of x and cosine x in this identity by 1 minus 1 over r squared for sine x and by 1 minus 2 over r squared for cosine x. We do it now and we get that sine of x is 1 minus 1 over r squared, therefore sine of x squared will be equal to 1 minus 1 over r squared plus cosine square x. Cosine x is 1 minus 2 over r squared, therefore cosine x squared is 1 minus 2 over r squared, and it is equals to 1 according to this algebraic identity. In the next step, we will define that t equals to 1 over r squared and we substitute 1 over r squared in this equation by t. We do it now and we get that this equation will be equal to 1 and 1 over r squared is t, so it is 1 minus t squared plus we have here 1 and 2. We have in the numerator 2, so it is 2 times 1 actually, because you can multiply everything by 1. So we have 2 times 1 over r squared, so it is minus 2 times and 1 over r squared is t, all squared, and it equals to 1. Here we can open the brackets on this side of the equation. And we get that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2 times t, plus 1 minus 2t squared is 1 squared, that is 1, plus 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t, and it equals to 1. So here we have 1 on both sides of the equation, so 1 gets cancelled. After cancelled 1, in this side of the equation we have t squared plus 4t squared is 5t squared. And we have here minus 2t minus 4t is minus 6t. We have also here 1. And it is equals to 0. So we can find out that five t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the formula. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. So the only thing Now, actually, in our specific quadratic equation, that is to say, 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally the coefficient c equals to 1. The only thing that we have to do is to put the data of our specific quadratic equation inside this general formula for x, and we find out the value or the values of t, because x equals to t. So we do it now, and we get that again x equals to t, so we substitute x by t, and we get that t equals to minus b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b square, b is minus 6, therefore b square is minus 6 squared, that is 36, minus 4 times a. A is 5, so minus 4 times 5 is minus 20, times c, that is 1, so minus 20 times 1 is minus 20, divided by 2a. A is 5, therefore 2 times 5 is 10. So in conclusion, we have found out that t equals to minus 6 plus minus square root of 36 minus 20 over 10. So t equals to 6 plus minus, and 36 minus 20 is 16, and square root of 16 is 4. Okay. So again, 36 minus 20 is 16, and the square root of 16 is 4, divided by 10. So here we have two solutions for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 2, 10 over 10 is 1. So according to the first solution, we actually found out that t equals to 1 unit in its length, and according to our definition, again t equals to 1, and according to our definition, t equals to 1 over r squared, so here we substitute t by 1 over r squared, and according to this equation, t is equals to 1 over r squared equals to 1. Here we multiply this equation by r squared, and we get that r squared equals to 1. We take out all the equation, and finally we get that r equals to 1. So according to the first solution, the values r of this segment is equals to 1 unit. Here also the second solution. According to the second solution, t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution, t equals to 1/5. But according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared, and we get that 1 over r squared equals to 1/5. Here we cross multiply this equation, and we get that r squared equals to 5. Here we take out of the equation, and finally get that the values r that we are looking for is equals to the square root of 5 units, or in terms of numbers, it is equals to 2.2366 units. Okay. Okay, again, we actually found out that the radius of the circle is equal to either square root of 5 units in its length, or in terms of numbers, is equal to 2.236 units. But we also have another solution. According to the first solution, the radius r of the circle is equal to 1, so r equals to 1. But really it is impossible that the radius r of the circle will be equal to 1. Why? Because of the fact that we know that BD, or side DB, equals to 2 units, and DB is definitely not the diameter of the circle. Again, DB equals to 2 units in its length, and it is definitely not the diameter of this circle. So write it down. We know that BD is not the diameter of the circle. Again, side BD or chord BD is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter in any circle is the longest chord in any circle. Okay? So, therefore, the diameter of this circle is 2r, and 2r must be greater than dB, that is not the diameter. Again, the radius 2r of this circle, r is the radius, therefore 2r is the diameter, so the radius 2r must be greater than dB, it is not the diameter, must be greater than dB, that is not the diameter, but BD equals to 2, so 2r must be greater than 2, you divide this inequality by 2, and when you get that r is greater than 1, r is greater than 1, so the solution that r equals to 1 is incorrect, because r must be greater than 1. Okay? And you have to live with the second solution that is possible for the radius r of this circle. The radius r of the circle either equals to the square root of 5 units in its length, or in terms of numbers, it is equal to 2.236 units. Okay, so in the next step, we'll summarize the lecture. In this lecture, we found out the radius of this circle. We know that chord AC equals to the square root of 2 units in its length, chord DB equals to 2 units in its length. This is angle BED, that is equals to 45 degrees in size. Again, our mission is to find out the radius of this circle. So first of all, we join points A and D together by a straight line. By joining points A and D, we can get the peripheral angle DAB. This is peripheral angle DAB, and we define the size of this peripheral angle DAB as x over 2. We know that peripheral angle DAB subtends on chord DB. So from point O, that is the center of this circle, we join points O and B together by straight line, and join points O and D together by straight line. In this way, we create that the center angle DOB. This is the center angle DOB that subtends on the same arc, arc DB, arc on the same chord, chord DB. Exactly like this peripheral angle BAD that also subtends on chord BD. And according to rule 4, or according to rule 13, the center angle is twice as large as the peripheral angle that subtends on the same chord or the same arc. So we know that both the center angle DEB and peripheral angle DEB and peripheral angle DAB, they are both subtend on the same arc, DB, and therefore the size of the center angle must be twice as large as the size of this peripheral angle DAB. And the size of this peripheral angle DAB is x over 2. Therefore the size of this center angle DOB that subtends on the same arc RDB must be equal to x, twice as large exactly. So if this peripheral angle DAB equals to x over 2, then the center angle DOB that subtends on the same arc DB must be equal to x. So this center angle DOB equals to x. In the next step, we defined the peripheral angle ADC, this angle as y over 2. Peripheral angle ADC subtends on chord AC. In the next step, from point O, that is the center of this circle, we join points O and A together by straight line, and we also join points O and C together by straight line. By doing this construction, we added the center angle AOC. This center angle AOC subtends on the same arc as AC, exactly as peripheral angle ADC, and therefore, according to rule 13, the size of this center angle AOC must be twice as large as the size of this peripheral angle ADC. So the size of this peripheral angle ADC is y over 2, therefore the size of peripheral angle AOC must be equal to y over 2 times 2, that is y. Okay. In the next step, actually presented to you a new rule, and we implemented a new rule in our drawing. The new rule is rule 4. I'll put this on rule 4. According to rule 4, the exterior angle to the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have this triangle. Inside this triangle we have angles A, B, and C. Those three angles, they are all defined as the interior angles of this triangle. While this is angle A, that is defined as an exterior angle, well, because it is located outside this triangle. And according to this rule, rule 4, the size of the exterior angle A, will be equal to the sum of the two angles that are not adjacent to it. Angle C adjacent to this angle, and the other two angles that are not adjacent to it is A plus B. And therefore, the size of this angle E, according to rule 4, must be equal to A plus B. Again, E equals to A plus B, according to this rule, rule 4. Actually, we can implement rule 4 in our drawing. Why? Because in our drawing, if you focus on the green triangle ADE, in this green triangle ADE, x equal x over 2 and y over 2, and this angle, they are all defined as the interior angles of this green triangle ADE. And this angle 45 degrees, it is defined as an exterior angle of this green triangle ADE. Now we can implement here rule 4. According to rule 4, this angle 45 degrees equals to the sum of the two angles that are not adjacent to it. This angle is adjacent to it, and the other two angles that are not adjacent to it is x over 2 and y over 2. And the sum of those two angles is x over 2 and y over 2, and this will be equal to 45 degrees according to rule 13. Okay. So, repeat again, according to rule 4, the exterior angle 45 degrees equals to the sum of the two interior angles that are not adjacent to it. The two angles that are not adjacent to it are x over 2 and y over 2, and the sum of those two angles is x over 2 plus y over 2. So this exterior angle 45 degrees equals to x over 2 plus y over 2. 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees, and 90 degrees equals to x plus y over 2 times 2 is x plus y. So 90 degrees equals to x plus y. We subtracted x from this equation and finally found out that y equals to 90 degrees plus x. Again, this is equation 1, and according to this equation 1, y equals to 90 degrees plus x. In the next step, I presented to you the law of cosines, and we implemented the law of cosines in our drawing. The law of cosines is true in any triangle, so here we have triangle ABC. This triangle ABC could be any triangle. The size of side AB is A, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle theta. So according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Here we added to this equation 2 times AB cosine theta and found out actually that 2 times AB cosine theta plus C squared equals to A squared plus B squared. And here we subtracted C squared from this equation and finally found out actually that two times AB cosine theta equals to A squared plus B squared plus C squared. Here we divided this equation by 2 times AB and finally found out that cosine theta equals to A squared plus B squared plus C squared over 2 times AB. Now we can implement the law of cosines in our triangle. I copied the this is triangle BOD that I copied from the original drawing. Actually, OB and OD are both the radii of this circle, and therefore they are equal to each other. Each of them is equals to R, and side DB equals to 2 units in its length. DB equals to 2. Now we can implement here the law of cosines. According to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared over 2 times r. Again, cosine x equals to r squared plus r squared minus 2 squared over 2 times r. Okay. 2 times r is 2r squared, and r squared plus r squared is 2r squared. So in conclusion, we found out that according to equation 1, cosine x equals to 2r squared minus 4 over 2r squared. 2r squared over 2r squared is 1, and we have here minus 4 over 2r squared. Here we divided both the numerator and the denominator by 2. Minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. Okay. Again, cosine theta equals to 2r squared minus 4 over 2 times r squared. Okay. And here we have, according to equation 1, we found out that cosine x equals to 2r squared over 2r squared is 1. And here we have minus 4 over 2r squared. So it is 1, and we divided both the numerator and the denominator of this expression by 2. And we got that minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we found out that cosine x equals to 1 minus 2 over r squared. So this is equation 1, and then I copied this triangle AOC in a new page, and we implemented the law of cosines in this triangle AOC, ACO, or AOC. So actually, this is the triangle AOC, the closest from the original drawing. OA and OC, the both the area of the circle, that equals to R, and AC equals to the square root of 2. Now, according to the law of cosines in this triangle AOC, cosine y will be equal to r squared plus r squared minus square root of 2 squared, that is 2, over 2 times r, that is 2r squared. Okay, so r squared plus r squared is 2r squared minus 2. And here, r squared plus r squared is 2r squared, so in total, in the numerator of this expression, we have 2r squared minus 2 divided by 2r squared. Again, 2r squared over 2r squared is 1. So we have here 1 minus 2r, 1 minus 2 over 2r squared. Okay. So again, according to this equation, we should found out that cosine y equals to 1 minus 2 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. 2 over 2 is 1, and 2r squared over 2 is r squared. So in conclusion, we found out that cosine y equals to 1 minus 1 over r squared, while cosine x equals to 1 minus 2 over r squared. Okay. And we already found out that y equals to 90 degrees minus x, therefore we can substitute y in this equation 2 by 90 degrees minus x. We did it, and we found out that cosine y is cosine 90 degrees minus x, that is equals to again cosine y equals to 1 minus 1 over r squared, and cosine x equals to 1 minus 2 over r squared. According to equation 1, y equals to 90 degrees minus x. Substitute y in this equation 2 by 90 degrees minus x, and found out that cosine y is cosine 90 degrees minus x, and it is equals to 1 minus 1 over r squared. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So we can substitute cosine 90 degrees minus x by sinus x according to this trigonometric identity. So we did it, cosine 90 degrees minus x equals to sinus x, and it is equals to 1 minus 1 over r squared. This is according to equation 1. But according to equation 2, we found out that cosine x equals to 1 minus 2 over r squared. So we have two expressions for sine x and cosine x. In the next step, I presented to you trigonometric identity that said that sinus square x plus cosine square x equals to 1. And we already found out that sinus x equals to 1 minus 1 over r squared, and cosine x equals to 1 minus 2 times r squared. Now we substitute actually sinus x and cosine x by those two expressions, and we actually found out that sinus square x is 1 minus 1 over r squared plus cosine square x, and cosine x equals to 1 minus 2 over r squared. Therefore cosine x squared will be equal to 1 minus 2 over r squared, and it is equals to 1 according to this trigonometric identity. Repeat again, we substitute cosine x by 1 minus 2 over r squared. If cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 r squared plus sinus x squared. Sinus x equals to 1 minus 1 over r squared, therefore sinus square x will be equal to 1 minus 1 over r squared. Okay, so conclusion, we found out that 1 minus 1 over r squared, this is actually sinus square x, plus 1 minus 2 over r squared, that is cosine square x, equals to 1 according to this trigonometric identity. The next step is substitute 1 over r squared by t, and we found out that here we have 1 minus 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t, and we found out actually that this expression will be equal to 1 minus t squared, and we have here 1 minus 2 times 1 over r squared. 1 over r squared is t, so 2 times 1 over r squared is 2t. So we substitute this expression by 2t, and in total this expression equals to 1 minus 2t squared, and it equals to 1 according to this trigonometric identity. Okay. Repeat again, we shall found out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets on this side of the equation, and finally found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2 times t, and we have here minus 1 minus 2t squared equals to 1 squared, plus 2t squared, that is 4t squared, minus 4 times ac, that is actually minus 2, so it is 1 square plus 2 times square, that is 1 square, plus 2t squared is 4t squared, and minus 2 times 2t is minus 4t, and it equals to 1. So here we have 1 on both sides of the equation, so 1 will get cancelled, also cancelled 1. In this side of the equation we are left with t squared plus 4t squared is 5t squared, and minus 2t minus 4t is minus 6t plus 1. So in conclusion we found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay. Another specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and the coefficient c equals to 1. The only thing that is left to do is to put the data, this data for our specific quadratic equation, inside this general formula in order to find out the value or the values of t, because x equals to t. So we did it. We found out that x equals to t, and it equals to minus b. b is minus 6, therefore minus b is minus 6, that is 6, plus minus square root of b squared. b is 6, therefore b squared is 6 squared, that is 36, minus 4 times a times c, minus 4 times a is 5, therefore minus 4 times 5 is minus 20, times 1, minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. a is 5, therefore 2a is 2 times 5, that is 10. Okay, so if we found out that t equals to 6 plus minus 36 minus 20 is 16, and the square root of 16 is 4 divided by 10. So here we have two solutions that are possible for a. The first solution for a is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. Okay, so according to the first solution, t equals to 1 unit. And again, according to the first solution for t equals to 1, but according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared, and found out that 1 over r squared equals to 1. Here, so 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally found out that r squared equals to 1. Here we took a root out of this equation, and finally found out that the radius r of the circle, that is the radius that we are looking for, equals to the square root of 1, that is 1. So the radius r of this circle equals to 1 unit in its length according to the first solution. And we have also the second solution. According to the second solution, t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution, t equals to 1/5, but t is 1 over r squared, so substitute t by 1 over r squared. According to this equation, 1 over r squared equals to 1/5, because multiply this equation, and I found out that r squared equals to 5. We took a root out of this equation, and I found out that the radius r equals to the square root of 5 units in itself. In terms of numbers, it equals to 2.236 units in its length. Okay, so the radius r of this circle, according to the second solution, is equals to either the square root of 5 units in its length, or in terms of numbers, is equals to 2 times 236 units in its length. So here we return to the first solution. According to the first solution, the radius r of this circle is equals to 1 unit in its length, but it is actually impossible that the radius r equals to 1. Why? Because of the fact that the diameter of a circle is the longest chord in the circle. Okay? and we have here chord dB equals to 2 units in its length, and we know that dB is not the diameter of this circle, and it is equals to 2. Therefore, the diameter must be greater than dB, that is 2. So the diameter 2R must be greater than 2. The diameter of the circle, that is 2R, must be greater than chord dB, that is not the diameter. Because the diameter is the longest chord in the circle. So 2R is greater than dB, or BD, that is 2. So from this equation, from this inequality, we derive that 2R is greater than 2. Here we divided this inequality by 2, and finally found out that the radius R must be greater than 1. The radius R of the circle must be greater than 1, therefore the radius cannot be equal to 1, that is not greater than 1. And therefore, because of the fact that the radius of the circle must be greater than 1 unit, we cancel the solution that the radius R equals to 1 unit, and we left only with the second solution, and we found out that the radius R of this circle is equal to either the square root of 5 units in its length, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.